Okay, I've got the top of the hour, so we're going to get started. I'd like to welcome everyone, and I hope you're all having a good day. The focus of this presentation is on ways to build recreational trails for walking, horse riding, and light vehicle use, as well as different methods for stabilizing embankments near trails. I'm your host, Corey Schneider, Business Development Manager with Presto Geosystems. I've been with Presto for 15 years, providing technical assistance and site support for our entire product line. We are located in Wisconsin and manufacture erosion control, stormwater management, and porous pavement products that are used all over the US and the world. We sell through an experienced distribution network that can provide local assistance on all of your projects. I have everyone muted now, so if you do have questions during the presentation, please type them in the question window and I will answer them at the end. Here are the things I hope that you get out of today's presentation. Understand how to properly build trails to reduce the impact to the surroundings, how different trail uses can affect the design, how to build through wetlands or other environmentally sensitive areas, and which products are most applicable for unique conditions that may be encountered. We are also going to touch on wall and slope design to ensure that embankments along trails remain stable. First, a little background on Presto. We worked with the Army Corps of Engineers to develop GeoCell technology in the late 70s and have been innovating ever since. Our products have been used in over 200 countries and in every state in the US. And we do go beyond simply providing a product. If you go to our website, which is prestogeo.com, you'll find a lot of design and construction resources available there. We do have experienced engineers on staff that will provide free project evaluations for any time you are considering using any of our products. And when we do one of those evaluations, we'll get it to our distributor as well as to the requester so that they can get you some budgetary pricing right away. So you'll know pretty quickly if it's something that will work for your project. We do also provide contractor support. So if you do decide to utilize any of our products, either Presto or one of our distributors can be on site to make sure that the product is not only installed correctly, but also as efficiently as possible. Generally speaking, we operate in 3 product areas: soil stabilization using our GeoWeb GeoCells, and they can be used in load support, slope and channel protection, as well as building green retaining walls. We also have a line of porous pavements, both vegetated and aggregate infill versions, and some lightweight reusable construction mats. Today we will cover some GeoWeb solutions as well as our aggregate porous pavement product and a few of our construction mats. An important thing to keep in mind as we go through this webinar: the trails that are made with our products are all considered permeable trails. That is, there's no impermeable paved surface being placed. The final surface is going to be stone or sand material. This lessens the environmental impact of the trail, reduces the amount of heavy equipment required for installation, often in difficult to reach locations, and improves the overall cost and speed of the project. We'll begin with what makes a good trail. The first aspect of the design is the reinforcement of the trail area, especially when the trail moves through sensitive areas. Keeping the path intact is how you keep people away from damaging vegetation or getting lost while wandering. The trail needs to be clearly delineated and needs to be reinforced enough to stay in place over time. Using products specifically designed to act as the reinforcement of the soil or stone means the trail will last longer and will not encroach on the surrounding environment. The next key to a well-designed trail is drainage. Ponding water can ruin a trail surface, and water that runs off the trail into unreinforced areas can scour and damage those areas. As I mentioned, all the products from Presto are considered permeable, and it is precisely for this reason. By keeping the surface permeable, the water infiltrates at the point of contact right where it hits the trail. The water can then permeate down through the product and into the subgrade, entering the groundwater system. The water won't pond at the surface and it won't run off or collect outside the reinforced areas. This keeps the trail in the same condition no matter the weather, so there won't be any flaws or failures created below the surface that you can't see. The last thing to consider when designing a trail is how to confine the surface. Loose aggregate, stone, or sand is easily moved under shoes, hooves, tires, and water, leading to ruts, holes, and generally damaged trail areas. When the trail surface is damaged, people are going to want to move around the damage, leading them off the trail and into unprotected areas, potentially disturbing sensitive environments. Keeping the surface in place is an important feature of the products from Presto. When the stone or sand is properly held in place, ruts cannot form and the material can't be washed away. This greatly reduces the amount of maintenance required because the trail's surfaces aren't degrading. Onto the products now. The first one that we'll look at is the GeoWeb 3-dimensional soil confinement system. This is a GeoCell, which may be a term you have heard before. It is similar to a GeoGrid, but is 3-dimensional, so it has depth to provide true confinement and can be used in a wider variety of applications. The GeoWeb system consists of two main components, cell size and cell depth. The cells come in three sizes, approximately 8 by 10 inch openings, 11 by 12 inch, and 18 by 20 inch. And the heights are 3, 4, 6, 8, and 12 inches. The combination of cell size and depth depend on the project details and loading requirements, but generally trails will use a 4 or 6 inch depth and a small or medium-sized cell. The seam strength is very important to the function of a GeoCell. The stronger the seam strength, the better designed the GeoCell is. A strong seam allows for heavier infill material, steeper and taller slopes, and better lifetime performance. The strength of the panel material, in our case high-density polyethylene, is also critical to the strength and performance of a GeoCell system. Here you can see a typical GeoWeb panel. It comes tri-folded and palletized. Each section has a nominal width of 8.5 feet with lengths varying from 12 to 58 feet. The panels are flexible, opening like an accordion, so they can follow the natural contours of the work site without being confined to a rigid set of dimensions. Here you can see our standard performance and materials specification summary. As you can see, there is a lot of information packed into our standard spec sheet. We won't go through it line by line today, but I at least wanted to provide you with a sense of what a typical GeoCell product spec should look like. You'll note that it contains a lot of detail on key material properties, including weld strength and ESCR, or environmental stress crack resistance. And just a general note when reviewing product spec sheets for GeoCells and any geosynthetic product for that matter, you want to pay close attention to any disclaimer language a product provider tries to sneak into the fine print. Recently, we've noticed a concerning trend where low-end product providers present performance data that appears to equal industry accepted standards on the surface, but then they add disclaimer language in the fine print at the bottom, stating that their specifications are subject to change without notice, or that the information shown is for general purposes and not intended for design. So just want you to keep an eye out for that, especially if you get hit with a request from a contractor on one of your projects to evaluate a substitute product. Our spec sheet contains no disclaimers, and we stand behind our numbers so you can deliver certainty in the solution as you build with materials you can trust. The GeoWeb is made from high stability inert materials, so the GeoWeb GeoCells are your permanent stabilization solution and will not degrade, leach, or release microplastics into the environment. GeoWeb is manufactured with premium high-density polyethylene resin with no fillers, polymer alloys, or other items. Our base resin is the same material used in environmental applications such as geomembranes and other environmental barriers to protect against the spread of harmful toxins. And our products have been third-party tested by accredited geosynthetics laboratories, confirming long-term stability against environmental factors such as weathering and oxidation. GeoWeb is lab tested to be durable for a minimum of 100 years in natural soil based on analysis in accordance with ISO 13438 and when subjected to UV radiation and accelerated weathering conditions in accordance with EN 12224. GeoWeb specimens retain 100% of their original tensile strength with no loss in mass or change in visual appearance. And as mentioned, made in Wisconsin. So if you do have any projects that are going to require made in the USA certification, we can certainly provide that for you. The GeoWeb system is a three-dimensional cellular confinement system, meaning that the GeoWeb panels have individual cells that are filled with an infill material that ultimately makes the final surface of the trail. By confining the infill material, the system distributes the loads and prevents rutting, and the cells keep the infill in place so that it doesn't wash away from stormwater runoff or move with traffic. The surface of the trail is going to be stable no matter what infill is chosen and require very minimal maintenance for the lifetime of the project. Let's look at some different options for building stable trails with the GeoWeb system. Walk, run, and cycle trails are meant for people, small animals such as dogs and bicycles only. This type of trail is typically not meant for equestrian use. These are the most common types of trails and can go along shorelines, through urban areas, or through forests or parks. The flexibility of the GeoWeb panels allows for smooth, natural-looking curves. The panels can be held open with stakes, as shown here, but those stakes are generally not permanent. They can be removed once the panels are fully filled. The panels can be laid either along the length or width of the trail, and they are easily field cut with a saw or landscape shears and are securely attached together. No matter the dimensions, there will be little waste as panels can be placed together in nearly any configuration. This is the finished trail surface using a local granite aggregate and allowing vegetation on both sides. The trail is clearly delineated and meets up with existing paved trails in the distance. The GeoWeb panels will keep the trail in place and level, minimizing surface erosion and potential runoff of contaminants into the adjacent waterway. This path used granite, but any type of stone is going to be acceptable as an infill material, with the only limitations being that it should be angular and have a maximum particle size of about 1/3 the cell depth. So you can use what is local to your area without needing to import expensive engineered aggregate. As I said, it's easy to field cut the GeoWeb panels to accommodate the trail dimensions, even rather narrow trails like this one between a road and protected wetland. By having the GeoWeb panels create the trail, water runoff from the road won't wash dirt into the wetlands because the water will be able to infiltrate through the permeable GeoWeb surface, keeping the dirt surface in place for a nice jogging path. Paths through neighborhoods or urban areas can augment or replace traditional sidewalks in places where drainage is a concern. Replacing broken and ugly concrete sidewalks with gravel surface paths allows for flexibility in design and aesthetic and will improve the safety of the walkway for pedestrians. These types of trails are good for any typical sidewalk traffic, but can also be designed to support cars or trucks. A 3 or 4 man crew can install about 1,500 square feet of GeoWeb panels per hour, including laying a geotextile fabric and infilling the panels. The geotextile helps create a separation layer between the natural subgrade and the infill material, especially important in areas of very soft subgrade such as a wet clay. We recommend overfilling the GeoWeb panels slightly when installing so that there is a wear surface over the panels and the plastic is not visible. This surface will become naturally compacted over time based on the trail usage. Having the panels slightly overfilled helps protect the GeoWeb material from vehicle tires or other potential damage. Equestrian trails are next, and they have some different requirements than walking paths. These trails have to be hardy enough to stand up to horseshoes while remaining smooth enough to avoid damaging their hooves. Horseshoes can pick up a surprising amount of dirt with each step, and with their heavy concentrated point loading can cause quick deterioration of the trail. If the trail is designed to withstand horse traffic, it is more than sufficient to handle hiking, biking, and small motorized vehicles. The GeoWeb trail system was utilized for erosion control for these equestrian trails. The gravel surface is resistant to rutting, and the 1-inch stone size is easy for the horses to walk over. This aggregate path will not get muddy or create sinkholes, so the surface will remain ready for use even after rain or other heavy use. Having a well-defined path also helps prevent damage to areas off the trail, and using the GeoWeb system allows for inclusion of natural markers, such as the large boulders we see here, on both sides of the system. Now we're going to walk through a case study for a shoreline trail in the city of The Colony, Texas. This project was a multi-use trail along the shoreline of a lake. The trail will see pedestrians, bikes, small vehicles, and potentially equestrian traffic. The client, the city of The Colony, wanted to follow the natural contours of the shoreline, which the flexible GeoWeb panels can easily handle. There was concern about the potential for uplift under the system due to the very high water table and lake level fluctuations, so additional steps were taken to prevent this from occurring. A series of polyester tendons were run through the GeoWeb panels and were anchored multiple times per panel. The tendons, in conjunction with the final infill stone material, prevent the GeoWeb system from lifting and deforming due to groundwater pressures. This is good practice in wet environments with potentially saturated soils. A well-graded decomposed granite was chosen as the infill material as it was readily available in the area. Using local materials is encouraged, though any type of stone is acceptable, again, as long as it is angular and allows good drainage. This means that you are going to want stone with limited fines so the water can percolate through. If the water can't infiltrate, you will get ponding at the surface, similar to a paved surface such as asphalt. So you want to make sure your infill material avoids this problem. And you should keep in mind that this material is going to be your final surface, so aesthetics may be a factor in choosing the material. Once the GeoWeb panels were installed, the infill was placed with a standard front end loader and then raked by hand to ensure all the cells were fully filled. The material should be placed on the outside of the panels as needed to match the final grade and meet up with the unexcavated areas. For ease of construction, you can drive your vehicles and equipment on the GeoWeb panels as soon as they are filled, right up to the limits of the filled area if necessary, so you don't have to wait for the entire system to be filled before using it. This can help minimize the impact of construction on the area, since you won't need to create access lanes or clear out excess vegetation on the sides. Small smooth barreled roller compactor finishes off the job. This is where having the wearing surface of overfilled material mentioned earlier comes into play. The compactor isn't driving directly on the GeoWeb panels, and you can easily visually confirm that no cell is underfilled. Again, the stone infill should have minimal fines. Less than 10% is ideal. Avoiding fines in your stone allows the system to stay permeable and not get clogged. Trails built with the GeoWeb system are a great example of green infrastructure by not disrupting the water cycle or impacting the groundwater flow. No additional stormwater infrastructure is needed when the trail surface is permeable, so there is minimal impact on the environment around the trail. Here we can see the nice clean trail created using GeoWeb, allowing for most uses without having to worry about needing constant maintenance. The path is clearly delineated while maintaining a natural look that people won't mind seeing in their backyards. A few months after installation, there was a massive rainfall event, over 7 inches of rain in a 3-hour period, which can be incredibly damaging both during and after the storm. Several portions of the trail were flooded to the point of standing water at the surface on and around the GeoWeb protected areas. But thanks to the GeoWeb system and the extra precautions such as the tendon system, the trail was not washed away as you might expect from an unprotected gravel trail. The trail was still usable, allowing maintenance workers access to the damaged areas for inspection and repair. No repair was needed to the GeoWeb system, and once the water was able to infiltrate, the trail was as good as new. When there is such a large rainfall event, the ground becomes saturated and doesn't allow water to infiltrate, giving it no choice but to stay at the surface and become sheet runoff. The GeoWeb system protects the trail surface against erosion when this happens, with the cell walls functioning as a series of check dams, keeping the infill confined within the individual cells. Then, when it is able, the water can infiltrate into the ground and the trail is still in good shape. Here's another project up in Kittery, Maine. In the spring of 2018, several storms violently swept through areas along southern Maine's coastline, devastating the beaches and trails of Fort Foster, a town-owned park in Maine. As you can see from these photos, the trails and maintenance road were washed out. To reconstruct the washed out recreational trail and maintenance road, 6-inch deep GeoWeb panels were installed at the site and infilled with 1-inch crushed aggregate. There were sections of the trail that sloped down to the beach areas, so to stabilize the 2-to-1 sloped areas down to the beaches, 4-inch depth GeoWeb sections were secured to the face of the slope with a deadman, tendons, and Atra tendon clips. Then the GeoWeb was filled with aggregate and covered with large riprap. By using the GeoWeb system, the park was able to armor the maintenance road, recreational trail, and slopes from future storm events. Here's a before and after photo of one of the trails. Since its original installation in 2018, the GeoWeb load support and shoreline protection system continues to perform as designed, allowing the community to once again enjoy the trail system and local beaches. This project in Vermont, we had an existing causeway which was used as a walking and biking trail across Lake Champlain, and it was blown out due to storms and had to be closed. The local distributor worked with the town and submitted a request for project evaluation through our website. And here you can see our recommendation of the mid-sized cell 4 inches deep. Installation took place in November of 2019, and the trail is holding up well after several significant storm events. One of the biggest questions we get is about cost. especially if this is a new technology for you or your area. Having an idea of how much the GeoWeb system costs compared to other stabilization techniques is very important. So here we have a basic comparison for the GeoWeb system for a load support application. In this case, a gravel surface road with subgrade CBRs of just 0.5% and HS25 loading. So this comparison shows the difference in both price and cross-section depth for an aggregate only unreinforced section using GeoGrids and geotextiles, and then two sections showing the use of the GeoWeb system, one with aggregate and one using on-site salvaged materials as the infill. You can see the GeoWeb system is both thinner and less expensive than the other methods, significantly so when on-site material is utilized. In fact, the 40% savings can be realized compared to the GeoGrid geotextile section, which does not allow for the use of most salvaged or on-site materials, as typically high friction angle, well-graded material is required with the use of grids and textiles. Of course, your aggregate costs and distance to quarries may vary, but this will give you a general idea of the savings that can be achieved. Now, moving away from the GeoWeb system, the next option illustrates similar confinement of infill, but within a rigid paver structure known as GeoPave. Unlike the GeoWeb material, which is typically 4 or 6 inches deep for trails, the GeoPave units are 2 inches deep and made from recycled high-density polyethylene. The GeoPave units have these rigid paver characteristics with specific features needed for performance with aggregate infill. The main one I want to highlight, though, is the monolithic mesh bottom. This is a molded in place mesh on the underside of the paver unit. This mesh keeps the stone infill from migrating under the unit, and the integrated nature assists in the overall rigidity of the paver unit. The lattice bottom spreads the load similar to a snowshoe, so the wheel loads do not create ruts. GeoPave units are locked together with a connection device to create a fully integrated, contiguous pavement that is highly resistant to traffic stresses. GeoPave was designed using a finite element analysis and will not lift up over time, as can be seen with other systems. And as I mentioned, the GeoPave unit is only 2 inches deep, which can be a real asset if the project requires a thin cross section due to buried utilities or high excavation costs. We'll now look at a few project examples. This project is an access trail for walking down to a swimming area on a lake. The walkway had to be ADA compliant so that everyone could use it. It was also important that the trail help reduce runoff into the lake, so the permeable nature of the GeoPave system was critical. You can see the eroded trail before stabilization, both the trail surface and the surrounding areas, and the new trail area on the right stabilized with GeoPave. The protected system will help prevent erosion from stormwater runoff and to be a smoother surface for walkers walking on for visitors. Here's another trail in a wetlands area. In this case, the GeoPave units were placed directly on the subgrade, but a geotextile separator fabric and a base layer of aggregate underneath the panels can be incorporated to support heavier loads or add additional detention. No matter the section, the entire system creates a flat, stable surface and supports the anticipated loads. The same principles that we discussed with the GeoWeb system apply here as well. By using an open graded aggregate stone with minimal fines content, the water can infiltrate at the point of contact, reducing surface runoff, and the individual cells can find the aggregate, preventing rutting and washout of the stone for a stable walking surface. A major concern here was protecting sensitive tree roots from impact damage. The GeoPave units are a great way to provide tree root protection by creating a bridge over the roots, so there's no direct contact from vehicle or pedestrian loads that could harm the trees. This bridge lasts the lifetime of the GeoPave trail and allows the trees to grow unimpeded. One of the great things about building trails with the GeoWeb or GeoPave system is the amount of choice you have over the final look of the system. 2 rock colors were chosen at this site to delineate the parking from the walkways. A light colored crushed limestone was used for the parking areas, and a contrasting reddish brown buckshot crushed aggregate for the walkways. Additional delineation such as concrete parking stops or snap delineators can be included to help create a sense of separation within the overall GeoPave system. This project ultimately earned LEED Gold for all of the low impact structure and landscape elements. Protecting the local watershed was the primary reason for the inclusion of permeable parking and walkways utilizing the GeoPave system. These pavements also perform as natural on-site stormwater detention, storing water in the base for natural percolation without the need for a large isolated detention pond, which would have been an unattractive nuisance on site. The GeoPave units come in 20 by 40 inch panels covering about 5.4 square feet, but they can easily be field cut or staggered to accommodate curves. So you are not looking into you're not locked into a linear path. The system was a great choice for this project with a quick and easy installation, the ability to allow water to flow through the system and not run off into the pond, and providing a smooth, clean surface for walking. The standard GeoPave units are black, but a tan GeoPave is an option that allows natural blending with light colored stone. Again, the options available for the final design of the trail are what make using this system so versatile and a great choice for any project. The last option for trail surfaces is the GeoTerra system, which are construction mats that are strong yet lightweight and don't require any fill. Because no fill is required, they are perfect for areas where infill resources are scarce. Because there's no fill material, GeoTerra trails won't kill the existing vegetation they are placed over. They are open on the top and bottom and allow for vegetation to grow through them for as long as they are in place, which is essential for minimizing environmental impacts for pathways. GeoTerra units cover approximately 5 square feet each and can be connected to cover a larger area as needed. The mats are strong enough to support heavy vehicle and construction traffic loads and have enough flexural strength to bridge soft soils without warping or cracking. The GeoTerra units are connected with strong metal connectors to essentially form a floating road through wetlands with very soft soils. The connected mat system distributes loading across the pavement, minimizing potential for rutting or sinking in soft, muddy soils. In some areas of Alaska, hundreds of miles of ATV trails cut across wetlands and stream beds, causing extensive damage to natural preserves. ATV riders can cause the loss of vegetative cover and habitat values. GeoTerra mats offer a great solution for low impact access in these wet and environmentally sensitive areas. The preferred method is to place the units across the entire trail width, but in some cases, just in the wheel paths is acceptable. As planned, indigenous grasses regenerated through the permeable open-celled GeoTerra mats, ultimately semi-camouflaging the product with the natural environment and protecting the vegetation from damage. In this case, the system ultimately ended up as a permanent structure, and the GeoTerra mats will be able to last for as long as needed. The last section is going to pivot from the flat surface of the trail to the embankments that may be alongside or near the trail. Green walls can help create the space for trails to run through and work with permeable trails to allow water flow and promote vegetation. The same GeoWeb GeoCell technology that creates the trail surface can also be adapted to create retaining walls, such as this vegetated levee. The GeoWeb panels are stacked vertically on top of one another to create the wall, allowing for more horizontal space for the trail to be placed. The primary benefit of the GeoWeb wall is to create a stable, natural living structure with vegetation for aesthetic appeal. The open front fascia allows rainwater to infiltrate. The wall structure can also absorb some runoff from the top of the wall, such as from walking trails. While vegetated walls are most common, aggregate-filled walls are also possible. Using the same open graded aggregate we have been talking about, water can infiltrate through the wall so there isn't runoff onto your road or trail. An aggregate wall may be useful when you don't want to worry about maintaining vegetation in an area, such as an emergency response space or in areas where vegetation is difficult to establish. Walls are designed as either gravity or reinforced walls in the same way as mechanically stabilized earth or MSE wall systems. An advantage they have over MSE block walls is flexibility in poor soil conditions. Their relatively lightweight and flexible nature allows them to tolerate reasonable differential settlement very well. Another advantage over traditional walls, such as gabion basket walls, is the relatively shallow embedment depth of the wall and the ability to create a very steep wall face, as steep as 80 degrees. It is always necessary to consider live and dead loads that the wall will experience, especially when placed near trails or roads. Dead loads would be things such as buildings or soil slopes above the wall, while live loads would be construction traffic and long-term vehicle traffic. When possible, the load should be placed away from the edge of the wall or fascia, but if not possible, the design will need to be robust enough to support and withstand both live and dead loads. Having traffic barriers at the top of the wall, such as this wooden fence, will help keep the loads away from the GeoWeb system, which can help with the design. We'll now look at a vegetated retaining wall case study. This project was faced with having to retain soils in a very problematic soft soil area, but piling systems were expensive and they wanted to maintain the natural environment. Concrete and modular block walls were considered, but ultimately they chose the vegetated GeoCell wall for its natural aesthetics and lower cost. Here you can see that the wall structure is constructed with a slight setback to allow for topsoil fill and vegetation in the front face. The backfill material is a good drainable aggregate. The wall can be seeded either by mixing the seeds in the soil before installation or by hydroseeding or broadcasting once installation is complete. As mentioned, the system's inherent ability to withstand some differential settlement in soft soil environments was extremely important at this site. The wall had varying heights along its length, which was easily accommodated by the GeoCell system. By using the GeoCell wall, they didn't have to bring in invasive equipment such as augers or H-piles, speeding the installation process. Here's the completely vegetated wall. The horizontal terraces allow rainwater collection, helping to minimize runoff and erosion. Pretty much any type of grass or flowering vegetation will survive on these walls. So by using local vegetation, upkeep can be kept to a minimum. Presto Geosystems offers a free software for designing GeoWeb retaining walls and slopes. It's available on our website, which again is prestogeo.com, and can be used by engineers and designers to determine if the GeoWeb system is appropriate for your projects. There are a lot of resources on the website on how to use and interpret the software, but we're always happy to help with questions or recommendations. So far, we have looked at trail surfaces, trail surface construction, and vegetated retaining walls. GeoWeb can also be used for erosion protection in a surficial manner. This is a good way to protect slopes against erosion when the slope is shallower than what would be required for a retaining wall and globally stable, around 60 degrees or shallower. If there are questions about this type of application, we are happy to talk you through it. There are three main infill types for slopes depending on the type of protection needed: topsoil, aggregates and granular material, and concrete. We'll focus on topsoil and vegetation infill, as that is typically what is selected in trail applications to keep things looking as natural as possible. Here's a simplified diagram showing how the different system components interact with the GeoWeb to form a complete system. We'll talk about each of these components next. To begin, we have our slope with some standard dimensions. The first thing to go down is the geosynthetic layer, which can be geotextile, geomembrane, geogrid, or any similar product. They aren't always required, and we typically try to stay away from them in vegetated applications, but we can make recommendations based on project details. Then the GeoWeb is put in place. Note how the GeoWeb has a horizontal turn near the top of the slope. This is important for crest anchorage and erosion control. We have two options for anchoring. One is using stakes or anchors. These are placed mid-slope and at the crest. The number and spacing of stakes is dependent on the slope dimensions, including slope length and slope angle. The other option is to use tendons and a deadman, with the deadman being a buried pipe, concrete anchor, or earth or rock anchors at the crest. The GeoWeb is then filled with the desired infill material, and if vegetated, an erosion control blanket or hydroseeding is used until vegetation is established. The ATRA key is the first component for a completely integrated system, connecting each individual panel of GeoWeb into a single web that covers the slope. It allows for faster installation of the GeoWeb and will last the lifetime of the project, ensuring that the slope is protected and that the GeoWeb system will not fail under anticipated loads. The specific engineering values of the ATRA key will ensure the system holds up to loading over time, without the corrosion seen in staples or the failure of underperforming cable tie systems. As slope angles increase, the driving force of the infill material exceeds the available frictional resisting force, and additional anchorage is required. The ATRA anchors, which are our ATRA clips on top of number 4 rebar, hold the GeoWeb to the slope and penetrate into the ground. If corrosion resistance is required due to project conditions, we can provide a high-density polyethylene ATRA speed stake that is designed to work with the GeoWeb. For long, steep slopes where the native soil is highly erodible or over a surface that cannot be punctured, such as a geomembrane, tendons can be used. The ATRA tendon clips transfer the load from heavy infill material to the tendons and crest anchorage system. Only the ATRA tendon clip is specifically designed to fully transfer safely and securely the forces placed upon the geocell. Every accessory and every feature has been designed and tested to specifically work together so that we go from problem to design to construction solution with a system where the modeling replicates the real-world forces. Now we'll take a very quick look at a couple of slope protection projects associated with trails. The American Tobacco Trail is a 20-mile rails to trails project running from Durham County to Chatham County in North Carolina. This slope had to be reconstructed after it was excavated in conjunction with the replacement of a culvert. After the culvert was replaced, the slope was regraded to its original 1.3 to 1 slope and needed to be revegetated. The GeoWeb slope protection system proved to be the perfect solution. Another great example of using GeoWeb for slope protection on a trail is the Lance Armstrong Bikeway in downtown Austin. And you can see from this photo that rather than establish grass, they actually put small plants into each one of the cells. So you really aren't limited by the type of vegetation that you can place into these cells. In summary, Presto Geosystems offers GeoWeb, GeoPave, and GeoTerra that can meet any trail design needs, as well as GeoWeb for earth retention and slope protection near trails. Each product is designed to protect the surrounding environment while offering a low maintenance surface that won't wash away during heavy rain events. We offer a complete solution, including connections and anchoring options. And part of our complete solution is our technical assistance. I mentioned earlier, we provide free project design evaluations. The form is on our website, which again is prestogeo.com. You can fill it out with as much information as you have, including attaching documents such as geotech reports, and send it to us. And then within 3 business days, but usually faster, we provide a complete design evaluation, including infill recommendations and anchorage requirements. We will work with you to get you the best design for your project. I would also like to introduce a new web-based software, Presto Geo P3, where you can plan projects yourself within this portal. This software offers a suite of geotechnical calculation tools designed to support engineers, contractors, and project owners in completing value engineering evaluations using GeoWeb geocells and GeoBlock and GeoPave porous pavements. You can check out the software at prestogeop3.com. We deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specs so you can deliver certainty and build with materials you can trust. We have no disclaimers or concerning fine print. So recently we have made it faster and easier for you to obtain your PDH certificates. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your webinar dashboard will keep a record of on-demand webinars completed along with PDHs earned. Please note that certificates for live webinars are managed separately from the on-demand webinar dashboard. So you won't find your certificate from today in there, but you will receive an email from GoToWebinar within the next 2 hours containing a download link to obtain your PDH certificate. In 2 to 3 days, you'll also receive a separate email from Presto Geosystems with more information about accessing the on-demand webinar dashboard with other helpful resources. If you do not receive either of the previously mentioned emails, please check your spam folder. Here's my contact info. I do want to thank you for attending and remind you that you can send questions to us at any time at info@prestogeo.com or directly to me at the email listed here. Go to prestogeo.com for a wealth of information, and don't forget to view our YouTube videos found by clicking on the YouTube icon in the upper right-hand corner of our webpage. I'll answer questions next, but if you have questions I don't get to or you think of a question later, you can respond to the follow-up email and we'll be happy to answer your questions and help with project recommendations. So now we will take a look at the questions that have been submitted. Scrolling up to the very beginning. The cover slide presents stakes restraining the system. Is there a need to permit the system to relax, and does it expand beyond the simple tension? I think we covered that. Certainly in load support or flat installations, the anchors are generally just needed for temporarily holding it open. Once you put your infill in there, you don't have to worry about that. Next one says, interesting, here in PA, gravel pavement is not considered permeable. I guess we could use sand or topsoil and grass. And yes, I am familiar with that restriction in Pennsylvania. It is disappointing. We've tried to get over that hump and explain that clean crushed stone is not equal to gravel. Gravel generally has fines and will be impermeable once it gets over compacted, but if you use a clean stone, it will be permeable. But you are correct, in Pennsylvania, a vegetated trail would be considered permeable. Are GeoWeb materials approved for use in Washington, D.C. in accordance with D.C. construction codes? Yes, we have done several projects in the D.C. area, so they are approved. Are the gravel or sand infill surfaces considered to be ADA accessible? Yes, they certainly, with the gravel, they are. And I believe we have sand infill projects that are considered ADA accessible as well. Question is whether this product can be used for access roads into detention ponds. The road will be used for desilting of the pond and portions stay underwater. Yes, we do an awful lot of access roads into detention ponds. Can be handled very easily. You know, assuming the pond doesn't have a lot of wave action, you can just use an aggregate infill for the entire thing, and we won't have any issues losing aggregate even when underwater. Are the products resistant to UV light and corrosive chemicals? Yes, the accelerated lab tests that we've done show that UV will not break down the material for well over 100 years. And that would be assuming that it was actually exposed, which it typically is not exposed to UV. And high density polyethylene is actually used for containers to store corrosive chemicals. So we don't have any issues with this material breaking down in almost any conditions. Is there any research information on the permeability of the underlying materials once the GeoWeb system has been installed? No, we're going over the top of the underlying materials, so that permeability should not change much. I do understand that, you know, with traffic, your subgrade might get slightly more compacted, which could impact the permeability. But the great thing about GeoWeb is that it does distribute those loads over a wider area, reduces contact pressure below wheel loads, and therefore greatly minimizes the amount of compaction of the subgrade. Are you able to test the subgrade for density using GeoWeb? Well, you could test the subgrade for density prior to placing the GeoWeb. Yeah, there's not really going to be a way to test it after the GeoWeb has been installed, though, no. General maintenance frequency and cost for the various GeoWeb applications for the various projects for which the products have been used. Tim, that's a very general question and really can't be answered. I mean, all project conditions are different. Type and frequency of loading, what sort of environment it's through. If you do have a specific project that you're looking at using GeoWeb and want to send me some details separately, we can certainly make an estimate on type and frequency of maintenance. Very often these trails are also used by heavy duty maintenance vehicles. Can the GeoWeb handle such heavy loading? HS20, yes, we can very easily design this for HS25 loading. And in fact, we do intermodal yards and ports that have much heavier loads than that. So we can design the system for pretty much any loading. Have you used wood chips as a material in your systems? We have on occasion. I would typically only recommend wood chips for, walking path / bike path. They're not going to work very well if you need to put any sort of vehicles on them, but if it's just a walking path, wood chips will work perfectly well. Yes, the webinar is recorded, and as I mentioned in the slide right at the end, you can access it through our webinar dashboard. Do we have photos of the steep wall installations? Yes, I did show a few photos of steep walls. If you want to, you can go to our website, prestogeo.com, retaining wall area, and then construction tools. Or if you would like to, you can shoot me an email and I'll reply directly with some links so you don't have to go looking around for them. Did I mention the horizontal spacing of the tendons on a slope? No, because it does vary. Steeper the slope, the more tendons that you're going to need. That's part of the project evaluation, and we will recommend that spacing on a case-by-case basis. Do I need special equipment to put Atra accessories into the ground? We do have a GAD that works with a pneumatic hammer, which fits right over the top of the Atra anchor stakes, but it's not really required. You could just use any sort of pneumatic hammer and it just might slide off this anchor a little bit. Where would you recommend GeoWeb versus GeoPave? Typically what we see is GeoPave being used more with foot traffic in more like commercial installations, and then the GeoWeb is kind of more of a, I don't know how to say it, like industrial type applications, or if you have a trail that's, really kind of out in the middle of nowhere that gets maybe less traffic, then GeoWeb would work. Again, if you want to send an email with some project specifics, we can talk about which one might be most suitable for your application. Are these products appropriate for use as a trail within the floodway? Full inundation, I think we covered that with the City of the Colony project. Yes, they can certainly be used when fully inundated. Ron asks if we provide in-person presentations. We sure do. If you want to send me an email, Ron, either myself or the local distributor can set something up with you. Is there a maximum depth for the surface material? I don't really understand that question. The GeoWeb comes in 3, 4, 6, 8, and 12-inch depths. So I guess the maximum depth for the surface material would be 12 inches. Has it been used on stream banks and channel turns? Yes. Has it been used in the state of Indiana? Yes, quite frequently. Have your systems been used to lessen ocean beach erosion? We have a few applications like that, but we get a lot of fight back on that because people generally don't want plastic on their beach. It'll certainly work if we can get over the hump of putting plastic right into the beach. When used in place of a stone-based MSE retaining wall, do the bottom layers get anchored to the soil other than footing? Nope, no anchorage is required, just the footing. And no, the anchors aren't anchored to each other either. It's just frictional resistance that holds them in place. Is there any stair options with GeoWeb? Yeah, you can certainly build stairs out of them. Just set each layer back by 12 inches or so and your stair is built. PDH certificates automatically distributed. Yes, I covered that on the last slide, and that will cover all of the questions. And we're just under 1 hour. So again, thank you all very much. And send any email questions directly to me, and you should see your PDH certificates within the next couple of hours.